In this lesson, we will talk about the circle theorem. We talk about angles within cycles. Under that, we will actually talk about angles in a semicircle, and we'll also talk about angles at the edge and the center of a cycle. Okay, so my name is J. Double. If you have not subscribed to this channel, I urge you to do that so that you will receive notifications whenever we upload new contents. So let's begin. Angles in a semicircle is always 90 degrees. All right, so let us have this cycle drawn, and we also have the diameter of this cycle. Okay, so this is the diameter, and what this rule is saying is if you have an angle that is being formed in any of these semicircles, that angle is always 90 degrees. Okay, but the two sides of that angle will actually be intercepting the diameter at the point of intersection of the circumference at the two edges. Okay, so let's see, for example, here. So we have two chords. These are two chords because they intersect the circumference of this cycle, and they form the angle. Okay, so this angle is always 90 degrees. Once those two chords intersect the cycle exactly at the point of intersection of the diameter, okay, so the angle that is being created is that angle we are talking about. So it's always 90 degrees. So here this would be 90 degrees. Okay, so looking at also this, we have this as the diameter. If you draw an angle, okay, this is the angle, and the two sides of this angle intercept exactly at the same point of intersection of the circumference of this cycle and that of the diameter. So the angle that is being formed here is also 90 degrees. So it could be also in this form. You can clearly see the two sides that form this angle intersect exactly at the same point of intersection of the diameter and that of the circumference of this cycle. So this is also 90 degrees. Okay, so let us see the next one. Angles at the edge and center of a cycle. The angle at the circumference is half the angle at the center. Okay, so if you see this a diagram, all right, you see this diagram, we have actually two angles, and the first angle is actually right here in the center of the cycle. All right, and the sides of forming this angle are from the center of the cycle to the circumference of this cycle, meaning they are just the radius. Okay, these are the radius of the cycle, but at two different locations. Okay, so if you draw another angle whose sides intersect the two respective points, and the both of them form an angle at the edge of the circumference of the cycle, this rule is saying that the angle at the circumference is actually half of the angle that is in the center. So if we have 100 degrees here, then it means this will be 100 divided by 2 will be 50 degrees. Okay, so let us see. If we have this same angle has been shifted, you see that the two sides of this angle intersect the point of intersection of the sides of the central angle at the circumference of this cycle. So you realize that the angle that is at the circumference here is the same as half of that of the angle that is in the center of this cycle. So this will also be 50 degrees. So you will have 50 degrees here, 50 degrees here. So if you clearly see here, is like we actually held this this angle and we shifted it all the way to this point. Okay, so it did not change, only that the directions of these sides actually was shifted. Okay, so let us see another one. We see here also we have this angle that is in the center, and we have this at the circumference. So if this angle in the center is 130 degrees, the angle in this at the circumference is half of this 130 degree, which would be 65 degrees. Okay, so if we are considering this other angle, which is 230 degrees, so we'll draw another two sides that will be intersecting the circumference at this edge. So it means this angle is twice that angle, okay, that angle that is here at the circumference. So it will be 230 divided by 2 will give you 115. So this angle is 115. So let's see some examples. Number 1, line AB is the diameter of the below cycle. Angle CAB is 50 degrees. Calculate angle X and Y. All right, so we have this diagram and we have angle CAB. So this angle here is 50 degrees. So we have the 50 degrees here. So we are to find the value of angle X and the value of angle Y. Okay, so in order to find the value of angle X, we know that angle in the semicircle. So angle S is an angle that is in the semicircle, because the problem tells us that line AB is the diameter. So this line AB is the diameter. Okay, so since it is the diameter, it separates this cycle into two semicircles. So any angle that is formed within the semicircle, according to our first rule, is actually 90 degrees. So it means this X value is 90 degrees because it is an angle that is in a semicircle. Let's see for angle Y. So this is angle Y. Now we have 50 degrees here and 90 degrees. So we have to find angle Y. And if you clearly see here, this is a triangle. And so we say the sum of the angles in a triangle is 180 degrees. So we know that. So since we have 50 here and we have 90 here, so we can be able to find the value of Y. So Y will just be equals to 180 degrees minus these two, the sum of these two angles, 50 plus 90. So that will give you 140, and you subtract that from 180, you will have 40 degrees. So it means angle Y is 40 degrees. Let's see a second problem. Line XY is the diameter of a cycle. What is the sum of angle A and B? So this is the diagram for this problem, and line XY is the diameter. So it means we see an angle here, and this angle is an angle that is within a semicircle. So we know definitely the unknown angle is 90 degrees, and the reason is that it is an angle that is within a semicircle, so it's 90 degrees. Okay, so it is an angle that is within a semicircle. Okay, so we have that as 90 degrees. Okay, so now let us find A plus B. So for A plus B, we also see that this is a triangle, and the sum of the interior angles of a triangle is 180 degrees. So this becomes 90 plus A plus B must be equals to 180 degrees. So the sum of an angle in a triangle is 180 degrees. So we have 90 degrees plus A plus B must be equals to 180 degrees. And we are to find the sum of A and B. So we have the sum of A and B. So what we do, A and B is the one that we are actually finding. So we just transpose the 90 degree. So A plus B becomes 180 degree minus 90 degree, which is A plus B is 90 degrees. So the value of A plus B is 90 degree. Okay. We do not have much information to actually determine what is A and what is B. But what we know is when we add the two of them, we have 90 degrees. Okay. All right. So let's see problem 3. Calculate angles A and B from this diagram. All right. Okay. So for angle A, angles at the edge is half the angle at the center. Okay, so this is our second rule. We know the angle at the edge is half the angle at the center. All right, so the angle at the center is 122 degrees, and we see A is the angle at the edge. All right, so it becomes 122 degree divided by 2. So that will give you A is 61 degrees. So here we will have 61 degree. All right, for B, if you look here clearly, B is just the same as A. It's like we actually shifted this angle from this point W to Z. All right, so we say the same as the above. The angles has just moved round the edge a bit. Okay, so we've just shifted this angle a bit to this point Z. So it will be the same. B will be equals to 122 degrees divided by 2, because this 122 degree is the angle at the center and B is the angle at the circumference. So that becomes 61 degrees. Let's see problem number 4. Work out the two labeled angles. The two labeled angles are angle S and angle T. Okay, so let us find angle S. Angles on the straight line is 180 degrees. So if you see here, you clearly see that 72 degree and angle S are angles on the straight line. Okay, so their sum must be equals to 180 degree. So we have angle S to be equals to 180 degree minus the 72 degrees that is here. Okay, so that will give you 108 degrees. So angle S is 108 degree. Angle T, if you see here, angle T, we will have this is a triangle, so the sum of the angles within the triangle must be equals to 180 degrees. So we say triangle ABO is isosceles, okay, as two sides are the radius of the cycle. Okay, so the two angles at the base will therefore be equal. So angle T will just be equals to 180 degrees minus 108 degree divided by 2. Okay, it's because these two angles are equal. So it means we will have 180 degrees minus 108 is 72 degrees divided by 2, which is 36 degrees. So thank you and see you in the next video.